Welcome to our presentation today, where we will be covering remoting protocols, their genesis, new remoting protocols that are available in the market today, and a comparison, and also, of course, the integration of remoting protocols with VDI and how you can architect VDI solutions and pick the right remoting protocol in your own environment. So just as a high-level overview, we'll be covering the genesis of remoting protocols, where these protocols came from, a little bit of the history there. We'll walk through Citrix and Microsoft Terminal Services and see how the early protocols evolved. And then finally we get to desktop virtualization, where then there was a protocol explosion with a large number of vendors entering the fray. And we look at what each one of these protocols really desires from a feature perspective and what they want to deliver to end users. We look at IT considerations, things that you should keep in mind. We look at a protocol comparison. We'll talk a little bit about the VDIworks protocol called VideoOverIP, and then we look at the future as well. So remoting protocols have been around for a long time. Essentially what they do is they take a user experience from a centralized computing location. That can be a mainframe, it can be in modern day times it can be a virtual machine, but originally in the 60s it used to be mini computers and mainframes and time sharing systems and so on, which were connected over a variety of different protocols to terminals, and these terminals were text-based and they would show the user interface that was delivered by the mini computer. And you could have more than one person use a terminal, and therefore you could do time sharing and multi-user scenarios. Now as time moved on, these protocols also became a lot richer in their capabilities, and in the 80s the MIT X-Window Consortium, later on became the X-Window Consortium, but this group out of MIT essentially created the X protocol, or XDMCP. And with this we saw several modern features. First of all, the ability to remote an entire desktop, so you could see the entire desktop that was being generated or computed in a central location, and then have that remoted out to a system that was on the other end of a network. And you also saw for the first time what is now referred to as seamless window mode, where you can run a single application, and instead of having the entire desktop remoted out, you could take a single application window and have that sent across using this protocol. On the Windows side and on the PC side, products like PC Anywhere and Carbon Copy were pioneers, and they allowed you to connect to a PC and see the screen, the graphical screen, as you would if you were sitting there locally. Performance, of course, was not very high end, but for remote administration purposes they worked fairly well, and for remote file sharing they worked fairly well. Then a very innovative product called DeskView X actually brought the XDMCP protocol to the PC. And now you could have a PC being used as essentially an X terminal. You could connect to a remote Unix system. You could see the entire Unix operating system show up on your PC even though you weren't running Unix locally. And an interesting piece of trivia, if you guys remember the old Matthew Broderick movie called War Games, remoting protocols of course played a huge part in that. In fact, Matthew Broderick logs in from his Data General terminal into the Pentagon's supercomputer and tries to essentially play this game, which ends up being a real simulation which could cause Armageddon, and ultimately Matthew Broderick and his girlfriend and the old professor finally step in and save the world from nuclear holocaust. So with that, from the early X-Window and text-based protocols, things evolved, and a couple of companies started to play a very key role in this evolution, and those two companies were Citrix and Microsoft. Citrix was founded at the end of the 80s in 1989, and the original product was essentially a multi-user remote computing stack that sat on top of IBM's OS2 operating system. Now, OS2 isn't around, but Citrix's relationships developed beyond IBM, and they partnered with Microsoft, which was then working on Windows NT, which was going to be this multi-user, multi-threaded system. And in fact, Bill Gates had invested a lot of capital in trying to up-level the entire Windows platform into a true, multi-user operating system. And for this, he even actually recruited from Digital Equipment Corporation the chief architect of VMS and brought him on board at Microsoft. And then, that person actually became the chief architect for Windows NT. Citrix started to collaborate with Microsoft and then developed a remoting protocol and multi-user enablement on top of NT. And then from that, Terminal Services was born. So now you could have multiple users logging into a Windows system remotely and using it just like the big Unix systems of old. Citrix launched its WinFrame product and then MetaFrame and actually licensed the code base from Microsoft. And this partnership actually became, very integral to the development of Citrix as a company. They were able to differentiate themselves from Microsoft, and their protocol called ICA targeted the higher end experience, and RDP, which was the Microsoft product, Microsoft protocol, that was targeted essentially at system administrators that wanted to remotely log in and manage a Windows workstation or a Windows server. Now today, of course, all of this has changed, and Citrix and Microsoft do find themselves competing in various different ways. Recently, Citrix bought a company called ZenSource, and with that they acquired a hypervisor, which Citrix is now calling ZenServer. Now that product competes with Microsoft's Hyper-V, which is Microsoft's hypervisor, and then at the same time Microsoft has also evolved RDP through RDP version 7 and now RemoteFX to really start focusing in on the higher level, higher end experiences, and in that sense now impinging on ICA territory. Now, terminal services were able to fulfill a very specific market need. In fact, the overall market share for terminal services expanded to about 2% of the corporate computing PC market. And call centers, niche applications, task workers, all of the folks that didn't really require high-end multimedia or high-end workstation capability, didn't require all of the computing capability of a system, they could use terminal services, and they worked fairly well. The user experience wasn't terrific, it wasn't focused on video, and then the other big aspect was that you essentially had one operating system and a large number of people were using this operating system at the same time. So if you were running applications and they were misbehaving, you could cause stability issues for all of the other users on that same system. So the isolation, in other words, wasn't very tight. Now with VDI and hypervisors, all of this changed. With VDI, you now have a virtual machine which acts as a container, and an individual operating system copy runs for each user. So you have one OS, one user, which you did not have with terminal services. So all your applications are isolated. And because the operating system is essentially an unmodified copy of Windows or Linux, you have full app compatibility. And you don't need to modify applications in order for them to run in this VDI environment. Now with VDI there was a need for a new generation of protocols, and there was a desire on the part of both vendors as well as the IT community to evolve VDI beyond the use cases that terminal services and Citrix had been fulfilling thus far, and to actually take this technology into multimedia remoting and full-fledged workstation type experiences. And of course, because VDI is a very promising technology and does deliver a large number of management and security and total cost of ownership benefits, a large number of vendors basically entered the fray, and we had this protocol explosion. Microsoft invested in RDP, bought a company called Callista, used that technology to develop RemoteFX. HP invested on the higher end with their remote graphics solution RGS protocol, which they designed for higher end traders and multi-monitor experiences and so on. Wise added sideband channels that accelerated RDP for multimedia redirect, and they call that TCX. Citrix, of course, continued to evolve ICA into what they now call HDX for the high definition experience. Quest bought a connection brokering company called Provision and therefore got interested in VDI, and then they developed another sideband to RDP which they call EOP. A company called Qumranet, which was focused on Linux and the KVM hypervisor, got bought by Red Hat, and their iSpice protocol is now part of the Red Hat Linux distro. Teradici, of course, a Canadian company that originally focused in on an ASIC to do compression and remote protocol, developed the PC over IP protocol, and then of course VDIworks with their video over IP protocol. Now, every protocol wants to deliver some benefits and some capabilities, and we've tried to sum these up on this slide. Obviously, in order to deliver a great experience, you need to have a high frame rate. You can't have a choppy experience, you can't have video lagging. You need to have a high frame rate, so every protocol wants to be fast. The protocol also needs to be flexible and open. So for example, if I pick a particular hypervisor, I would like my protocol to run on it, but then if I shift hypervisors or want to move to a physical system, I'd like my protocol to make that transition and not cease support simply because I changed a hypervisor. The same thing goes for hardware, so I would like my protocols to run on a large collection of thin clients, because in my large enterprise I might have different hardware from different vendors, and the protocol needs to be able to support all of that. Then in addition to the speed, it needs to be high fidelity, as close to lossless as possible, full color capabilities, and an expansive set of resolutions. Doing all of this, I don't want to eat too much bandwidth, so it needs to be a bandwidth efficient protocol, and it also needs to be processor efficient, and this is very important because the remoting protocol in many cases is a piece of software that's running on a host and a client, especially on the host, which is running maybe a large number of VMs, and those CPUs are being shared across many users. We want the remoting protocol to not impose too much of a CPU burden on the host side, so that the density off of a VDI server can remain high. Ideally, we also want our protocol to be WAN capable, so that it works with a variety of different latency and jitter criteria, and it's fairly bandwidth tolerant. It has features like local cursor, so I don't want the picture of my mouse pointer to be sent to me across a WAN, because the lag is such that when I move my mouse, and if the cursor is actually rendered on the host and sent back to me, that's a 2x delay. So whatever my latency is between my endpoint and the server, you can multiply that by 2, and that's how long I will have to wait for the cursor to update, and that's simply not acceptable because the cursor starts to feel like it's lagging. So you need to have features like local cursor for immediate movement. It needs to be simple and reliable. You don't want too many dropped connections. You also don't want the complexity of a very sophisticated, very extensive VDI platform that enables the protocol. Ideally, you just want to install a simple host component and a simple client component, and you connect the two and you're done. Now many protocols are tied so closely to hypervisors and VDI platforms that you really can't achieve this simplicity, and that's one of the things that protocols should aspire to, and many of them do. And then lastly, of course, you want codec independence. So a lot of the protocols that focus on sideband acceleration, where they use trickery and magic, what seems like magic, to augment RDP, will simply take a running video on the host, and instead of using RDP to ship those images across the wire, they'll create a sideband and redirect that multimedia stream over to the client. And what that means is that the client needs to be able to decode that multimedia stream. And on the host side, the sideband channel needs to be able to detect the specific kind of full motion video stream that can be redirected. So this has two downsides when you do the sideband trickery. First of all, you need to have a codec on the client, and if you want to play a wide variety of different kinds of video, then you need to have many codecs, and you need to keep those codecs up to date on the client, and this becomes a pain from a management perspective. And the other downside, of course, is that your sideband will not work for every kind of full motion experience. And what this means is that if you're running Flash, or if you're running, say a CAD model that's rendering and it's not video stream that needs to be redirected, well, then that may not get detected, and it certainly won't get redirected and decoded on the client the way you would expect it to. So now that we know what protocols are out there and what they're kind of aspiring to, let's look at it from the other perspective. From an IT manager's and end user's perspective, what do we need to keep in mind? First of all, let's start with usage scenarios. What kind of usage scenarios do we need to support? For example, do we have users that need to access our VDI infrastructure over the WAN? Do we have people that require dual or quad monitor experiences? Do we have people that are doing full screen multimedia, full screen video playback? Is codec independence an issue because we don't want to have that management burden imposed on us from a thin client perspective? Do we need DirectX support? What kind of cost metrics are we looking at? What can we invest in the host and client hardware? Because some of these protocols, for example, do require ASICs, and the hardware for that is expensive. And so, again, you have to keep all of that in mind. And then last but not least, peripherals. What kind of peripheral remoting do you need? Is USB important? What kind of audio in-out capabilities do you need? Then moving on, let's look at the hypervisor requirements. Do we have a multi-hypervisor environment in our company? Do we expect that we'll have Microsoft Hyper-V running side by side with VMware at some future point in time? Is committing to a single hypervisor something that we're comfortable with? And then, of course, on the thin client side, do we need a zero client? Do we need a thin client? Do we have full-fledged PCs that we're repurposing? If we are using thin clients, what kind of processor capabilities do they have? So there's a lot of stuff that we have to keep in mind. And then the protocol itself doesn't make a VDI environment. We need a connection broker, we need support for multiple operating systems, we need management capabilities. So are there good management tools, and is there an ecosystem around that protocol that helps us manage it, deploy it, broker it, and truly get value in a real IT environment? Now, if you look at many of the protocols out there, we've created kind of a comparison here for you, and you can look at this. I don't want to run through everything here, but one of the big differences that you'll see between, say, VideoOverIP, which is the VDIworks protocol, and many of the others, is VideoOverIP is truly platform independent. It'll run on top of Hyper-V, it'll run within a VMware virtual machine, it'll run within a Xen virtual machine, and it'll run on physical hardware. It'll deliver many of the high-end capabilities that more quote-unquote expensive protocols deliver. For example, multi-monitor and support for multimedia. It has USB redirection built in as well. And on top of all of this, VideoOverIP is the kind of protocol that isn't doing any of the codec trickery. So you don't have to worry about having codecs on a thin client. There's no sideband redirect or anything like that. It's an honest to goodness full capture of what's happening on the host, compression, and then shipping that across to the client. So what this means is that every kind of video experience, every kind of motion experience will be accelerated. It's not limited to certain kinds of videos. You can play anything within a web browser. You can run a Flash video. You can run an MPEG video. You can run an AVI file. You can have a CAD render, and everything is picked up and accelerated by VideoOverIP and shipped across the wire. So we're very proud of what we've done with VideoOverIP, and as you can see in this presentation, we are very focused on delivering many of the benefits that we believe customers want and IT departments are looking for. And all of the things that we talked about earlier, you know, the simple install, so you have a simple host installer which installs in like 5 minutes or less, and a simple client installer which installs in 5 minutes or less. And these are the only two components you need, and you're up and ready and you're in business. Now if you want to add a connection broker, of course we support that too, but at the very basic level, you know, much like many other protocols that are available from larger vendors, we're not going to ask you to install a multi-gig, you know, software stack just to get the remoting protocol going. It is fast and it delivers very high quality, high resolution images. It's, as I mentioned earlier, completely open. It'll run on any hardware, almost any hypervisor. It's very flexible. There's a lot of settings that you can tweak to really optimize the experience in your network environment. And it has multiple modes of capture at the host, and one of those modes does also allow for aero remoting. And then of course with peripherals, USB, and as well as analog audio in and out. So many other protocols basically just say, okay, if you want audio, just use USB for that. But we actually capture audio from the host and redirect it to the client without leveraging USB to do that. And then of course we have a number of other improvements. We've got a Linux client that's now available in preview for select customers, and numerous other innovations planned on the roadmap. So, you know, what can you expect in the future from remoting protocols? With VMware, of course, the view enhancements, soft version of PC over IP has been released. Of course, it's only available for VMware, so it's not open. And you can't really have an independent install of this. It's essentially a VMware bound product. Then we have the Callista acquisition resulting in RemoteFX from Microsoft, and now there's a large ecosystem that's developing around this. But again, RemoteFX will only work on Hyper-V, so it's not something that's open or something that will allow you to deliver experiences from any kind of backend. You're certainly limited in the backend that you can use. There's been a lot of questions raised about HP RGS and whether it's going to be supported or not going to be supported, and there's a variety of, you know, articles that are out there and lots of customers asking those questions. HP has definitely clarified their position, and they do say that they will continue to support RGS. And again, within the higher end, you know, trader markets and a lot of the workstation type scenarios where you have a fairly beefy thin client, RGS is a viable option. Now again, RGS is bound to hardware, so it's not going to run on non-HP hardware. So with all of these three that I've mentioned so far, you'll see you have these limitations in that, you know, if you want to use PC over IP, then you have to use VMware. If you want to use RemoteFX, you have to use Microsoft Hyper-V. If you want to use RGS, you have to use HP hardware. So, you know, that's certainly an opportunity that we've picked up on at VDIworks and are trying to create a more open alternative for people that are interested in that sort of thing. And then, of course, with ICE and Red Hat and KVM, KVM hasn't really been adopted as a, you know, VDI technology in any large scale. So if you look at, say, you know, VMs that are running on Xen or VMware that are used to deliver a VDI experience versus the same kind of numbers for KVM, you know, they'll pale in comparison. So it's kind of a niche play so far, and it's very Linux focused, and it is something that, you know, hasn't yet emerged as a real frontline option. And then of course we're continuing to invest in video over IP with lots of exciting innovations planned. You know, things like see-through windows where you can have a remote experience showing up, and then you adjust the transparency, and you can see your local desktop and your remote windows. So what we call desktop compositing, and numerous other innovations, including, of course, now we've delivered video over IP on the iPad, on the iPhone as well, so there are clients available for that. We're looking at an ARM port of video over IP. Lots of very exciting things planned for video over IP in the future. And if you're interested in learning more, including questions like how much bandwidth do you need for VDI, demonstrations of some competitive products like VMware View, or demonstrations of VideoOverIP, you can certainly click on these links and visit these for more information. So I hope you've enjoyed this, and if there are any questions, of course, feel free to shoot those over. In the live webinar session, we'll be able to answer your questions right away. You can also email us at info@VDIworks.com with any questions with regards to our products or anything in this presentation, and we'll be happy to address them. Thank you very much for your time.